Optimist Day celebrates y'all as like awesome humans and people who support their own communities. So I really appreciate that. Um, Ramon joined us for like a hot second and then he headed out. Okay, must have joined the wrong link. So I have a funny link or a funny glass half full type of comic here. If you want to take that out, have an early morning chuckle, I'm here with you. Um, is it also World Cancer Day? Oh wow, that sounds super important. I don't know, Christine. Is it? Is that today? I don't know. If it is, that sounds
Yeah, it is. I saw it on the calendar and then I also searched it up just to make sure it's today.
interesting. Does it just bring awareness to like cancers across the world, perhaps?
Yeah, it's the international community to end the injustice of preventable suffering from cancer.
Oh, interesting. So it's not just like awareness of all cancers, but it's like specifically for cancers that could have been preventable. Wow, very interesting. Wow, thank you for sharing, Christine. That's awesome. I must have missed it because I was just looking at the national day, so it makes sense that that's an international holiday. Wow, even more important than a national holiday. Interesting, cool. Thank you, Christine. All right, let's jump in. We have a few announcements. My first announcement's kind of silly, but I kind of love it. We need some pen pals, friends. Okay, so here's the deal. The sophomores and the juniors are becoming pen pals with the freshmen, but only if you want to, because we don't want you to like be a pen pal and not like it or like not want to hang out or like right back to your pen pal. But if you would, we need some pen pals to write some awesome letters to some really nice freshmen. These are my baby advisees. This is just a smattering of them. They're very sweet, but they have no friends because they've never been to hybrid high. So we would love, love, love if you would become their pen pal. It doesn't require very much. You don't have to like send a letter or anything. It would be like mostly via email. Um, if you want to, I'm super pumped to hear a few of you in the chat that want to. I would love to have you fill out this form. If you fill out the pen pal form, it takes like 2 seconds, like literally like it's your name and like, yes, I want to do it. Then they will give you all the information. They'll probably email you and tell you what to do. So if you could become a pen pal, my little advisees need little friends. I mean, they need big people friends because right now all they have is little friends and I need them to like, grow up a little bit. So they would really appreciate your support and they would appreciate your friendship. So then they would not be so scared because they have yet. I don't know if you guys have thought about this. Like, I know y'all are missing hybrid high. They haven't even gone to hybrid high. They've never even, like, a lot of them have never even been in the building or like talked to anyone. Um, so they want some friends. So if you're a nice human and um, you're willing to write a letter to them, I would really appreciate if you would sign up for the pen pals. So, okay, that was my like shameless plug. Please help my advisees. Then I wanted to review the schedule. I know it hasn't changed for y'all, but um, uh, yes, I would love to just share it with you. I'm like getting distracted by everyone chatting me. I love it so much. Please sign up. That would be awesome. Y'all are so kind. I knew I was asking the right class when I asked this class. So for pre-calculus, y'all have me from 9:45 to 10:30. And then I just wanted to remind you again that we do have open space office hours from 10:30 to 12. So if you have Spanish, go there and then come back to us at 11:20. Or if you have Spanish at 11:20, come to us at 10:30 and then jump off. Okay. Cool. Y'all have that advantage because you have me in the morning. So want to make sure that you know that that exists. For our last assignment, we were doing great. If you're Emma or Amaris, I'm looking for yours, but thank you for turning in the things that you turned in from your past assignments. We're at 94%, yay. Y'all did really great on your IXL. If for some reason you forgot your IXL password, let me know and I can pop that to you. I know it's getting about that time where we might forget. And then that brings me to the end of our announcements. Does anyone in the room have any announcements for us? I know a lot of us like lead clubs and like organize events and activities. Anybody want to publicize their thing that they're doing this week? No, feeling good. All right, cool. So shameless plug, sign up for the Pen Pals. Other than that, we are going to jump over to our notes. Did anyone take the notes already this morning? Did anyone take the notes already this morning? Yes. Okay. Amazing. Jimmy, Christine, and Mia. Mia L. And it looks like someone gave me a thumbs up. Let me find it. Maritza took it this morning as well. And Melissa took it this morning. And Kaylin took it this morning. Okay, so y'all, if you already took the notes, you should just work on the assignment. So your rooms are already open. You can jump into those rooms to work together. And if you need me to move you around so that you can work with someone who's already done, I'm happy to do that. So feel free to jump to those rooms if you're already done with the assignment, or I'm sorry, done with the notes. Is anyone done with the assignment? I guess I should ask that. Looking like nobody's done with the assignment. One more question. Wow. Impressive, Sarai. Can I open your room again? Christine, all the rooms are open. So I think on the bottom of your screen, you should have a breakout room button. You might see more. When you click more, you might see breakout rooms. It doesn't have that. Are you on your phone or computer? Computer. What do you see, like mute and stop and share screen? Do you see something that says like ... more? What the heck? That's so weird. That's very strange. I can't close it because Miss Flores has a breakout room. Let me see if I can move you. Let me see if I can move you. You need Sarai, Melissa, and Christine. Yeah, you definitely need to update Zoom. So if you're on Chromebook, you can download the Zoom app, like the Zoom app. And then if that will like help you log in there, and then it's like much easier. Like everything's better on Zoom. I know some of us are still like clicking the link, which is fine. But if you download the app and then click the link, it will work better. So let me do this. Let me move Sarai into a different room, and then I'll move her back. Okay, Sarai, maybe that worked. And then Melissa, same thing. Sorry, y'all. Thank you for waiting. If you are waiting for me, go ahead and pull up your notes from Canvas page. Thank you, Janet, for letting me know. Hi, everyone. It looks like a few people are jumping in here. Okay. I'm going to pull up my share screen. I think everyone who needed a breakout room is now in them. Let me know if that's not true. So tell me in the chat if you're still waiting for a breakout room and it's not working for you. And then we'll figure it out for you. All right, friends. If you're here with me, we're going to jump into our notes. Cool. Okay, so there's a lot written down. I might recommend, honestly, I might recommend pulling up the notes and typing on them today. I don't know if y'all like typing on your notes, but I do think that that might be helpful for today. If you don't like doing that, feel free to continue writing on paper, of course, but I want to make sure that you have like access to everything. So here, I'll go ahead and put the notes here in the chat if you still need them directly. So these are the notes. So if you want to log on and look at the, like type onto your own version, you can. Caitlin, we took attendance a little earlier. Here we go. Sorry about that. I think our Wi-Fi, it's no problem. I'll post that to everyone just in case. Thank you for the reminder, Caitlin. Cool. Okay. Have we thought about, dealt with logarithms in the past? What, if anything, do we know about logarithms? Did we learn about them in Miss Jolly's class? Fatima and Devin are like, yes, we've done them before. Fatima, did those extra S's mean that like you like logarithms? David's got a smiley face on his. We like them? Oh yeah, RSL, you might have done them with Miss Wall, for sure. I forgot, this class had Miss Wall. Y'all had Miss Wall, huh? When you were ninth graders for geometry. Oh, I love her so much. Do y'all want to know a secret? I'm gonna stop recording so you can know a secret. We're gonna resume. All right, so logarithms. It looks like there's some love of logarithms. It looks like we have learned a few of them before. Did we learn the loop-de-loop? This is my next question. Did you learn the thing where like you take the 2 and you loop it around the 4 and that equals a 16? Like 2 to the 4th power equals 16, like that? Yes, this is what we learned. I think I learned the loop-de-loop from Miss Wall, so that's good. I remember that. Okay, there is another way to think about it, which is that logs are basically the opposites of exponents. They're like another way of writing an exponent, right? So I could do, if this is base 36, I could say 36 to the power of log whatever. And what I do on one side, I have to do to the other. 36 to the 1/2 power here, like this. And that would cancel 36 and log 36 and give me just 6 equals 36 to the 1/2 power. Right, so this is a slightly different way of showing the same thing. But if you want to see how Miss Wall would do it, right, she would do 36 to the 1/2 power equals 6. 36 to the 1/2 power equals 6. Right? So these are two separate ways of doing the same thing. Let's vote. Do we like the loop-de-loop or do we like the raising it to the power? Somebody tell me in the chat. Loop-de-loop or raising to the power? Kaylin likes the loop. So far, she's the only vote. David says either is fine. Fatima says loop. Diana says loop. Walter likes the loop. Cool. Okay, so then since we're feeling familiar, I'm going to go ahead and have us jump down a little bit. Tell me what we know about this one here. It says log 100 equals x. What does it mean if there's no base on a log? It says log and there's no base. Yeah, we really do remember this. There's some people popping off in the chat. Kimberly says that it's a 10. The loop, yes. The base is a 10, right? The base is a 10. So then how could I write this? This is logarithmic form. How could I write this in exponential form? Exponential form. Devin's got me. 10 to the power of x equals 100. 10 to the power of x equals 100. 10 to the power of x equals 100. These guys here, right? All right. Did we learn about ln, the natural log, with Miss Wall or with Miss Jolie? Did we learn about natural log? Yes, we did. I do, but I can't remember. Thank you for your honesty. Yes, we did, but I forgot. Great. Let's just talk about natural log really fast. Natural log is has all the same powers as a common log. Common log is when you have a base of 10. Has all the same powers. It just has the base for a natural log is the number e. Anybody might be like, Miss, E is not a number, E is a letter. E is a letter, but in math, E is also a number. E, I think we talked about this on last maybe Tuesday. E is the number 2.71, I don't know. It like goes on forever and ever, like pi. I don't have very many of them memorized. It is roughly 2.718. And then it has a lot of numbers after that. It is an irrational number. So anytime that we have ln, we have the base of e, right? So natural log, this is ln, not in. Some people, there's always one person who's like, it's a capital I. I'm like, no, it's not, it's an L. ln, natural log. It's like kind of backwards, natural log. And the base is e. So how could I write this in exponential format? In exponential. So do the loop-de-loop with this guy. Yes, e to the power of x is 5 equals 5. E to the power of x equals 5. Thank you, Diana. Thank you, Devin. All right, so if the base is not written with a log, the base is 10. If the base is not written with a natural log, the base is e. All right, so something just quickly to write down in your notes if you don't have it. Cool. And then I think we are in a decent space in terms of writing them in exponential. Let me get an idea because I know I'm just seeing the people who are in the chat. Can you give me a fist of 5 on converting from logarithmic form to exponential form? How do we feel in terms of converting from logarithmic to exponential? All right, so 5 to the power of 1/2 equals x. 4 to the power of x equals 1/16. We're just converting from one format to the other. For sure. Cool. So it looks like most of us are 4s and 5s. So I'm going to give you this offering. I recorded it like you didn't know anything. And if you want to go ahead and watch the video to listen to, if you want to go ahead and watch the video in order to listen to it, you are welcome to do that. I appreciate you, person who's asking me to slow down a little bit. You do not need to write everything down. I'm doing a few examples on the screen just so we could like trigger our brains a little bit. I will definitely slow down a little bit on the next section, but I also want to just like give you like, have no fear. You don't have to write down everything that I have on my screen. There's lots on the screen for sure. Thank you for asking me to slow down. All right, we're going to do a little bit of estimating, right? We're going to estimate here for maybe 5 minutes, and then we're going to spend most of our time on equations. Okay. So estimating is when you have a logarithmic expression like this, log base 3 of 81. We're thinking 3 to the power of what could give me 81? 3 to the power of what gives me 81? 3 to what power gives me 81? Anybody know? I know 3 squared is 9. 3 to the third is 27. 3 to the fourth. 3 to the fourth, yes. Yes, friends, it is 3 to the fourth. So 3 to the fourth is 81. Therefore, this right here, log base 3 of 81, simplifies to the number 4, right? Simplifies to the number of 4. I can do this in my calculator. I can do this in my calculator. So I'll show you how to do it on Desmos because I think that's the calculator most of us are using at this point. Some of us have fancy calculators. I can do it on my calculator. I can go to functions here, and then I'm going to go to miscellaneous here. And then I'm going to click this one here. There are two options. Here's my common log. Here's log with a base right here. And then there's my natural log. So I'm going to click this one here. And then it gives me a chance to just type in the 3 and the 81, right? It's going to tell me that it equals 4. I could do this. It's called change of base. This is like the old school way. If you're using an old school calculator, you might do it this way. You do log of 81, so log of the big number divided by log of the base number. The base goes on bottom. So log 81 over log of 3, you get number 4. Okay, so using a calculator, we're able to also calculate that it is 4. Have we used calculators to calculate logs in the past? Does that feel familiar to us? Got at least one vote for yes. Okay, yeah, I think so. Okay. Okay, so when our logs are not, so this was a perfect number, right? Because 3 to the power of 4 equals 81. It's exactly the number 4. Sometimes we don't have that situation. So for example, we have log base 3 of 36. Does 3 to the power of anything equal 36? Like 3 to the power of any whole number? Yeah, no, right? Right? No, there's no 3 to the power of any whole number. So if I'm going to estimate, right? If I'm going to estimate, then I need to think, okay, what's close to that? So I wrote out my logic here. It says log base 3 to the 36 must be in between 3 and 4 because 3 to 3 3 to the third is 27, 3 cubed is 27, and 3 to the fourth is 81, right? So because 36 is in between 27 and 81, I know that log base 3 of 36 must be in between 3 and 4 because it's a little bit bigger than 27, it's a little bit smaller than 81, right? Bigger than 27, smaller than 81. So is it going to be closer to 3 or closer to 4? Any ideas on that? Yeah, closer to 3. Can someone come off mute and tell me why it's closer to 3? No off mutes today.
It's closer to 3 because it's 27 when you multiply it. When you use the exponent 3, it's closer to 27. And when you use 4, it's 81, so that's a higher number.
Yeah, absolutely. Thank you, Mia. Sending merits to you. Appreciate you coming off mute. I know it's sometimes challenging. So we know that it is closer to 3, just as Mia was telling us. So I'm going to go to my calculator, type in 36. Let's see if Mia was correct. Absolutely, it's 3.262. I'm going to go ahead and round there. Within this class, you should always feel comfortable using 3 decimal places. 3 decimal places, thousandths is usually the best decimal place, unless it tells you to do it to a different degree. So 3.262. Let's go ahead and take a moment. I want you to try this one here, log base 4 of 21. I want you to figure out what 2 numbers is it in between. What 2 numbers is it in between? Don't spoil it for everyone. So if you got the answer, go ahead and direct message me. What 2 numbers is it in between? All right, anybody got it for me? What two numbers? Miriam says 2 and 3. Walter's got me with, okay, so Miriam is saying 2 and 3. Walter says 4 squared and 4 to the third, right? So 4 squared, remember, is 16. And 4 to the third is 64. So 21 is in between 16 and 24, or 16 and 64. So it must be closer to 2 because it's at 16. So it must be closer to 2. I can go to my calculator to find out which is it closer to. Try 21, put our base of 4. We get 2.196. 2.196. How are we feeling with estimation? How are we feeling with estimation? Thank you for your votes. All right. Cool. It looks like we are at, we have the most in 5s, but we also have some 4s, 3s, 2s, and 1s. So I'm going to go ahead and do this one again. So here we have log base 3 of 105. So I'm going to think 3 to the power of what? So 3, I know 3, we'll just start with like 3 squared is 9. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth. You might not know that, but I had to use my calculator the other day. I was feeling like, whoa, that was a hard one for me for that moment. So I can see 3 to the fourth is 81 and 3 to the fifth is 243. 105 is in between 81 and 243. So I know that this log is in between 4 and 5, probably closer to 4 because it's closer to 81, right? So 3 to the fourth is 81. So I'm going to use my calculator to determine that. I have base 3 and 105. My exact number is 4.236. 4.236. So I'm using my calculator to calculate that. And I can see it was between 4 and 5. Okay. All right. Let's jump in a little bit. I'm going to leave my calculator up. Okay, so we have done some logarithmic form. We've also done some estimating. If either of these is feeling a little clunky to you, remember the video. I go into much more detail in the video, so you can check out the video. I do want to solve some log equations, so that is what we will do now. I want to highlight potentially that we may not get to all 6, just looking at the time now. So if you are interested in watching the other ones, you are welcome to do so on the video as well. But we will plug and chug through as many as we can. So here we have log base 9 of x equals negative 2/3. Okay. Go ahead and take a moment to write that down. Because x is in my, because x is inside of my log, I'm going to go ahead and do the loop-de-loop in order to get x out of the log. So I'm going to do my loop-de-loop. 9 to the power of negative 2/3 equals x. So for this one here, I could say, okay, I know a negative makes it go to the bottom of a fraction. I know a negative makes it go to the bottom of a fraction. And then I know that the 3 moves out in front. So I'd have the cube root of 9 squared still on the bottom of a fraction. And I know that equals x. This is super complicated, and I'm just interested in what the number is for x, right? I can type up here at this step, I can type this into my calculator. I'm going to go ahead and check that out. 9 to the power of -2 divided by 3 gives me this very small decimal. Right? I'm going to use 3 decimal places, just like we were talking about earlier. So x equals 0.321. And that is going to be my answer for this problem here. If I want to check my work, as always, I can plug x back into the problem. So I should have log base 9 of 0.231. And notice I did round, so it's going to be a little bit different than -2/3, right? -2/3 would be 0.6666666 forever and ever. I'm not going to have that because I didn't type in this exact number. If I did type it in, 120424784, you can see as I type in more numbers from my exact answer, it gets closer and closer to the exact answer of -2/3. Right? But for the time being on our papers, we only need to write down 3 decimal places. So we have this one here. Let's go ahead and try a second problem that is very similar, but uses the natural log. So x is in my log. What is the base here? What's the base with the natural log?
10.
It's 10 if it's log and there's nothing. But since we have
E?
the, yeah, natural log would be e. Yes, natural log would be e. Thank you. Perfect. So I have natural log of e. The x is in the log, so I want to get it out of there by using the loop. So I have e to the 3rd power equals x. X is by itself. I can do e to the 3rd in my calculator. So I'm going to go to my calculator. I'm going to find my, oh, I don't need to find e. I can use my ABC. Go to e. You can see e itself is equal to 2.718 to the power of 3. I get my answer here. X equals 20.086. Do remember to round. Since there's a 5 here, that would turn this into a 6. All right. Give me a quick update. How are you feeling about just these first two? These first two. We're just doing the loop in order to get them out. Okay. Thank you for your honesty, per usual. Awesome. If we were using a school calculator, how would we get E? Great question. On the school calculator, there's an E. Actually, it's like at the bottom. You have to press second and then maybe like the 1 key or the 2 key. Ooh, actually, now that I'm thinking, oh, I have one. Hold on. Dun, dun, dun. E is on the division sign. So you would press second and then you would press divide and it'll come up with the E. And just second, E. You just go like that. I don't know if you can tell. Oh, nope, not helpful. But you press E and then you could get that number there, the 2.7 number. Good question. Okay, cool. So it looks like 3s, 4s, and 5s. I'm feeling good with that. Let's go ahead and take a look at this one here, because this one looks like a log problem, but actually is much more simple because x is on the outside, and the log just includes the numbers. So if the log just includes the numbers here, we can just calculate this. right? Just calculate that in your calculator. So I'm going to go ahead and go to my log base, put 25 there, and then put 5 square root 5 there. It tells me 0.75 equals x, right? So be careful. This is different than this other problem because in the first problem, x was in the log. It was like locked into the log. But in this problem here, the x is actually on the outside, right? The x is on the outside. I did this problem in 2 other ways. If you want to watch the video, you can check that out. But the easiest way is just to remember if you have x, if x is not a part of the log, then you can just calculate it. Right? Just calculate. All right, let's go ahead and try this one here. So I have log base 3 of 2x plus 1 is equal to -3. Unfortunately, unlike the last one, the x is with the log, so I'm going to do the loop-de-loop. I've got 3 to the power of -3 equals 2x plus 1. 3 to the power of -3. I could use a fraction. I'm going to use my calculator. 3 to the power of -3, like that, is this very small decimal, 0.037 equals 2x plus 1. I'm leaving this ... here as a reminder that it's actually this whole number, right? It's not just this number. I don't want to round in the middle of my problem, so I'm going to remember that it is this big long number. I need to get x by itself, so I'm subtracting 1 on both sides. So I'm going to go ahead and do that on this part. I'm not going to go to the next line. I'm just going to subtract 1 in Desmos. So I get -0.963 ... equals 2x now, and now divide by 2. I want to divide that number by 2. So in Desmos, if I just put divided by 2, it's only going to divide the 1, but I want to divide everything. So I'm going to put parentheses around it and now divide by 2. That's going to divide the whole thing by 2 so that we have -0.481 equals x. I'm seeing a couple questions. I'm going to hit those in just a second. You can absolutely change. So one of the questions was, shouldn't we just change this into a fraction so that it's just not negative anymore? So we could say 1 over 3 to the third. 3 to the third is 27 equals 2x plus 1. Then I'm going to go ahead and subtract 1. So I would have 1/27 minus 1 equals 2x. And then I'm going to divide that by 2. Okay, divide that by 2. So if I did that in my calculator, it would look like this: 1 over 27, subtracting 1, and then dividing that by 2. I'm going to get that exact same number, -0.481 equals x. Just like that. So Caitlin, we could do it the same way. It's going to give us the same answer. Absolutely. Okay, I do want to acknowledge that it is 10:30. These last two, if you would, I'm not going to hold you accountable to doing them in your notes. So if you want to skip them, you can. But if these are important to you, you are more than welcome to watch them on the video. That's why I make the video. So we always have them for forever. Other than that, it is Thursday. That means it's almost the end of the week. If you need any support, we'll be here starting right now all the way until noon. So do feel free to jump back into this call after or before your Spanish class. That being said, I will see you next week, and I love you all. I'll see you soon. Bye, everyone. Bye, everybody. Bye, Kiara. Have a great day.
Bye, Miss. Have a good day.
Bye. Have a great day.